Hey guys, this is homework 10.4. Today we're going to continue talking a little bit about the normal distribution curve, but we're going to talk about something called the z-score. So let's just follow along at the top where you see the formula for z-score. Z-score of a data value. So this formula right here will help us to calculate a z-score. So it says a z-score for a data point x subscript I. That just means like a point within the set of data. And this is how we find it. We find z, the z-score, by taking that data point, subtracting the mean, and dividing by the standard deviation. And what this does is calculates how far from the mean in terms of the standard deviation a data point lies. It can be positive if the data point is above the mean or negative if it's below the mean. So let's try it out. Example number 1. Boys' heights in 7th grade are normally distributed. That means that they fit on that normal distribution curve we talked about yesterday. And the mean height is 62 inches and a standard deviation of 3.2 inches. Find the z-score rounded to the nearest hundredth, that's important, for each of the following heights. Show the calculation that leads to your answer. All right, so let's start. So the first value or data point is 66 inches. So we're going to use our formula to calculate it. So z, the z-score, equals the data point, 66 inches, minus the mean, which we were told the mean in the problem, 62 inches, and divided by the standard deviation, which we were also told in the problem, is 3.2. Okay, so if we simplify this, we get 4 over 3.2, which is 1.25. This is our z-score. Okay, part B. Now our data point is 57 inches. So our z-score would be 57, which is our data point, minus, again, the mean, 62, all divided by the standard deviation, which is 3.2. Okay, so if I simplify this, I get negative 5 over 3.2, which equals negative 5.6. Notice this was negative 5.6 because the data point, 57, was below the mean of 62. Notice in part A, our z-score was positive because the data point, 66, was above the mean, which was 62. Okay, so I'm going to ask you to pause the video and take a second to try part C on your own. Okay, so let's take a look at the back. Sorry, not the back, just below this. Z-scores give us a way to compare how far a data point is away from its mean in terms of standard deviation. We should be able to compute z-scores for data value and go in the opposite direction. So that means that maybe we're given a z-score and we have to find the data point, or we're given a z-score and we have to find the mean or the standard deviation. Just like we've learned before in the past, to manipulate formulas to find what we want from them. That's what we're going to do here, same thing. So I'm just going to write that formula for z-score down again. So z-score equals my data point minus my mean, all divided by my standard deviation. So example 2, Jeremiah took a standardized test where the mean score was 560. That is important. The standard deviation was 45. If Jeremiah's score resulted in a z-value of 1.84, what was his score to the nearest whole number? Okay, so we're working backwards a little bit. So we're going to plug in what they gave us. The z-score, 1.84. We're looking for the data point. The mean is 560, and the standard deviation is 45. Okay. So what can we do here to solve for our data point, or x? So what I'm going to do is I'm going to multiply both sides by 45. Okay, and now I'm left with x equals 560. X minus 560 equals 1.84 times 45. And then if I add 560 to both sides, now I have 560 plus whatever 1.84 times 45 is, and that gives us 643 to the nearest whole number. That's why it's 643. Okay. Let's keep going. So example 3. The lengths of full-grown sockeye salmon are normally distributed with a mean of 29.2 inches. I feel like that's going to be important, so I'm going to underline it. And a standard deviation of 2.4 inches, another important piece of information. Part A, find the z-score for sockeye salmon whose lengths are 25 inches to 32 inches. Round to the nearest hundredth. Okay, so in this problem, I'm just finding two z-scores. I'm finding the z-score when x is 25, and then the z-score when x is 32. Okay, so let's start with when x is 25. So I take my 25, I subtract the mean, I divide by the standard deviation. So my z-score is negative 1.75. Now I'm going to find the z-score when my x value is 32. So I take my 32, I subtract from the mean, divide by the standard deviation, and now my z-score is 1.17. Remind yourself, so that you make sure you understand this, why a z-score, or when a z-score is positive and when it is negative. So if you notice, when x was 25, which is below the mean, the z-score was negative, and when x was 32, which is above the mean, the z-score was positive. Okay, let's look at part B here. Use the z-score table. We are not going to be using the z-score table during this video today. To determine the proportion of the sockeye salmon population to the nearest percent that lies between 25 and 35 inches, illustrate your work graphically. Okay, here's another thing we're going to learn how to use the calculator for. So, a few things I noticed is that I want the proportion of salmon population to the nearest percent. So I'm basically being asked for what percent of the sockeye salmon is between 25 and 32 inches. So I can do this using a function on my calculator. So we're going to look together and we're going to write down the steps together on how to do this. So I'm going to bring up my calculator. And that way we can follow along here. Okay, so I am going to go to, on my calculator, I'm going to go to second vars, and that's the distribution button. So first thing is go to second vars, and that is called distribution. Okay, then I'm going to use the second one down, which says normal CDF. We want CDF. We do not want PDF. PDF is like computer, a PDF document. No, we don't want that. We want CDF. Make sure we always use CDF. Okay, we're going to press enter. Now, your screen might look different than this. This is what my screen looks like. Remember, I have like an older setting calculator. So this is what my screen looks like. Your screen may look different. So now what we're going to do is we're going to put in the information in a specific format. So you're going to do this with me. So the first thing we put in is what we call the lower bound. Then we put in the upper bound. Then we put in the mean. And then we put in the standard deviation. And then we close the parentheses. Okay? So let's do that together. So I am going to put in my upper bounds. Now notice it said between 25 and 32 inches. So I'm sorry, I'm going to put in my lower bounds. So between 25 and 32 inches, the smaller number is 25. Then I'm going to put a comma. The bigger number is 32. So my upper bound is 32. Then I'm going to put in the mean. Notice I'm putting commas in between everything. The mean for this problem was 29.2. Another comma, and I'm going to put in the standard deviation, which for this problem was 2.4. Now I'm going to close my set of parentheses, I'm going to press enter, and there we go. So to the nearest percent. This is a decimal, and I need to write it as a percentage. So 0.83826, going on. If I write this as a percentage, it's approximately, and it said oh, it said to the nearest percent. So if I multiply this by 100, it would be like 83.8. So to the nearest percent, this is 84%. There we go. Now you might get a different screen. On your screen, it might look, it might kind of lay everything out for you. So it might, instead of you having to know what to put in, it might say lower bound, upper bound, mean, standard deviation, and you just have to fill the numbers in rather than actually remember the order in which it goes in. So we'll talk about that tomorrow when you guys start using, you use the classroom calculators and you have to see which way to do it. Okay, let's go on to the next problem, which is example 4. And I know it also said to illustrate your work graphically. That's another thing that we're not going to do. We're going to use the calculator for a lot of this stuff. Okay, so let's go on to example 4. Example 4 says, if the scores on a standardized test are normally distributed with a mean of 560, important information, and a standard deviation of 75, answer the following questions using a z-scores and normal distribution table. Okay, so part A. Find the probability that a test picked at random would have a score larger than 720, round to the nearest tenth of a percent. Okay, when you hear like probability or like the last question, what we want to know is basically, so I'm going to kind of illustrate what we're looking for here. So here's our normal distribution curve. Our mean is 560, so that goes in the middle, right? Okay, and then we have like 1 standard deviation above, 2 standard deviations above, 1 standard deviation below, 2 standard deviations below, and so on and so forth. So it's asking us the probability a test picked at random would have a score larger than 720. Well, if the mean is 560 and the standard deviation is 75, let's figure out around where that would be. So if I take my 560, which is my mean, and I add the standard deviation, 560 plus 75, that gives me 635. So this number right here is 635. What if I add another 75? Let's check out where that is. That gives us 710. So this number right here is 710. So then that means that a little bit above this number is where we're looking, somewhere above this number. And we're looking at basically anything larger. So they're basically asking us like what percent of the data lies in this section of our normal distribution curve. There's a really easy way to find this, and it's just using the normal distribution, using the normal CDF that we just learned. So let's do that. So I'm just going to write my work right over here for this problem, and I'll take up less space for B. Okay, so I am going to go to second vars. I'm going to pull out my calculator here. Okay, so it's over here. I'm going to go to second vars. I'm going to go to my normal CDF, not PDF. And I am going to put in my information. So remember, it was lower bound, comma, upper bound. So it said that a test picked at random would have a score larger than 720. So think for a second. Is 720 the highest number or the lowest number? If it has to be larger than 720, then that means 720 is the smallest number. It's the lower bound. So for lower bound, I'm going to put my 720 in. Then I'm going to put my comma. And then for upper bound, I don't know what an upper bound is for this because it just says larger than 720. So I'm literally just going to write a really large number. What I do is I put 1 and then I put a whole bunch of zeros. Then put a comma. So I did lower bound, I did upper bound. Then I need to do the mean and then the standard deviation. So what did I say? The mean here is 560, so I'm going to write that. And, whoops. And then my standard deviation is 75, so I'm going to put that in. Oh, yeah, I'm mixing this up. Here we go. Comma, 75, close parentheses, and press enter. Okay, so here we go. So what I end up getting is 0.01644866368, and it said to round to the nearest tenth of a percent. So they want us to express it as a percentage, not a decimal, and they want us to round to the nearest tenth. So if I were to multiply this by 100, the percentage would be 1.64486368. Now round to the nearest tenth of a percent, so 1.6%. So 1.6% of the data lies over here and is larger than 720. Okay, let's try it for another one. So let's look over here at part B. Find the probability that a completed test picked at random would have a score less than 500. Okay, so again, I'm going to go back to my second bars. I'm going to go to normal C, D, F, and then I'm going to put in lower bound, comma, upper bound. So I need a score less than 500. So is 500 my upper bound or my lower bound? So we have to ask yourself. Well, if it has to be less than 500, a number less than 500 would be 400. I can't go higher, so 500 is my upper bound. So just like we did before, where we just put a really large number for our upper bound, since our lower bound we don't know, we're going to put a really small number. So I'm literally going to put like negative and then 1 and just a bunch of zeros. Comma, and now I'm going to put my upper bound of 500. Now I also need to put in my mean next, which is 560, and then my standard deviation is last. And then I close my parentheses, press enter. So we got 0.21185533337, and I want it to the nearest tenth of a percent, so I'm going to multiply by 100. That would be 21.185533337 percent, and nearest tenth would be 21.2%. 21.2% of the data or of the scores are less than 500. Okay, let's keep going. So let's take a look, part C here. Find the probability a completed test picked at random would have a score between 500 and 600. This is a nice question because we have an upper bound and a lower bound, so we don't have to do any of that, like pick a really small number and write it in, pick a big number and write it in. So we're going to go to second bars, normal C, D, F, and we are going to do our lower bound 500, comma, upper bound 600, comma, mean 560, comma, standard deviation of 75, and here we go. So I got 0.491243 times 100 is 49.1243. Nearest tenth is 49.1%. Okay, we got one more to do for this question. Find the probability a completed test at random would have a score between 600 and 700. Okay, so again, one more time. What I want you to do here, what's really important, especially because not all of you have calculators at home, is I want you to take a second to write in how you would do this in the calculator. Now what I mean is just write in normal, C, D, F, and fill in all the numbers that would go inside the parentheses in the correct order. So pause the video and take a second to do that. Okay, we are going to look at our last exercise, which is exercise 5. So the process is sometimes used, this whole process is sometimes used to determine particular data points percentile, which is the percent of the population less than the data point. Let me be clear about what this means. So if you remember ever going to the doctor's office and like when you were younger and being told like for your age, your weight is you're in the 75th percentile. That means that your weight is 75% of the population of kids your age have a weight 75% less than you. If you're in the 10th percentile, only 10% of kids weigh less than you. If you're in the 100th percentile, then you weigh more than everybody else. If you're in the 50th percentile, you are basically right smack in the middle, you're the average. So we want to know the average weight of a full-grown beef cow. The average weight of a full-grown beef cow is 1,470 pounds, with a standard deviation of 230. If the weights are normally distributed, what's the percentile rank of a cow that weighs 1,750 pounds? So this involves using a standard deviation curve. So I'm going to use my curve. What's really important is that you have an idea of what percentages go where in this curve. That's really important. So I'm going to start out, I know that what goes in the middle is my mean, and then I'm going to put in 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, and I'm going to put in also the same things for below. Okay, so from yesterday, hopefully you have somewhere some of these percentages, but let's fill them in. So within 1 standard deviation above and below the mean, that's 34.1% of the data. That's where 34.1% of the data lies. Then between 1 and 2 standard deviations, it's 13.6% of the data. And then between 2 and 3 standard deviations is 2.1% of the data, and then lower than 3 or higher than 3 standard deviations is just 0.1, lower than 3 is just also 0.1% of the data. This makes sense, right? Because the majority of the data lies in the center, and then the outliers are kind of at the ends. Those people that like stand out from the norm are at the ends. So let's use the numbers associated with this problem to try this out. So again, the average full-grown beef cow is 1470, so that goes right here in the middle. Standard deviation is 230. So I'm going to use my calculator or do it by hand, whatever you prefer, and I'm going to add 1470 and 230 to figure out what number goes 1 standard deviation above. So this is 1700. Then I'm going to add again my standard deviation, 230, so I know what goes here, 1930. And then I can actually stop because they're asking us what percentile rank 1750 is at. So 1750, if this is 1700 right here, then let's think 1750 is just 50 more. So it's not quite from 1 to 2, we've gained 230 because that was our standard deviation, right? So half of 230 is like 115. So it's like basically a fourth of the way between 1 and 2. So if this is halfway between maybe 1750, it's like right here. So we just want to think about like what percentile that would be. The way you figure out a percentile is you just add up all the percentages before it or to the left of it. So if I were to add up this 34, this 34, this 13.6, this 2.1, and this 0.1, that would give me a better idea of what percentile this is at. But remember, it's not quite here. It's a little bit after it, like right here. So let's take a second, and I'm going to calculate. Okay, so what I get is 84 when I add up all of these numbers where I just put or highlighted in green. So I know that it's going to be a little bit more than that, so that tells me it's going to be the 89th percentile. Again, percentile is just a way of telling us like how much of the data lies below that number. Okay? All right, guys, so this is where we're going to stop with exercise 5, and if you have any questions, make sure you jot those questions down to ask tomorrow, but we'll continue talking about this tomorrow.